Good evening, everyone. I'm thrilled to welcome you to today's presentation where we dive into a fascinating comparison between two fundamental data structures, the stack data structure and the binary search tree data structure. Our team has undertaken a project that implements an expense tracker using both of these data structures. Our objective here is to showcase the distinct characteristics and functionalities of the stack and binary search tree in a real world context. I'd like to introduce my team. Starting with me, I'm Anushka Baskota. My registration number is 2035 and I'm from the O2 section.
I am Sreejana Changkakati. My registration number is 2044. I'm from Motor section.
I am Ovi Singh. My registration number is 2051. I'm from O2 section.
Hi, my name is Misha Goyal. My registration number is 2056. I'm also from Ovi section.
Well, without any further ado, let's get started with our presentation now.
I will talk about expense tracker that uses a stack-based data structure. This means that it can follow the last in first out or LIFO principle, where the most recent expenses are stored at the top of the stack and can easily be accessed or removed. The stack-based implementation helps on focusing rapid memory efficient expense tracking without the complexity of extensive financial management features. Moving on to the next topic.
Binary search tree data structure. It's a data structure. It's a hierarchical data structure where we can easily search the elements that we want. Um, so, binary search tree is powerful way to organize and manage data, especially useful for tracking expenses. Unlike a stack-based system, it allows chronological storage and flexible access. Users can quickly find specific expenses, sort transactions, and conduct detailed financial analysis, making it a versatile tool for expense management and finance tracking. So, what are the key differences in stack and binary search tree? A binary search tree excels in organizing expenses with chronological storage and flexible access. Unlike stack-based systems, BST allows a quick searching, sorting, and in-depth financial analysis. While stacks are memory efficient for small data sets, BSTs shine with larger and complex data due to their hierarchical structure. Expense tracker using binary search tree. As discussed above, binary search tree is a more structured and sorted approach for expense management. This binary implementation provides advanced features such as efficient searching, sorting, and individual retrieval of expenses. This makes it well suited for users seeking comprehensive financial analysis, trend identification, and the ability to manage their expenses in an organized and sorted manner. Now, moving on to the next topic, that's the code.
So I shall explain the code. This is a C program that manages expenses using a binary search tree. It allows user to input expenses. Uh, there is a structure, okay, at the start of the program. There is a structure that is named as expense and expense node. Then we have insert function. The insert function inserts expenses into the binary search tree based on their amount. Then we have in order traversal. In order traversal function prints expenses in ascending order by amount in a table format. Then we have the display table function, which displays all our entries of data as a whole and together in the form of a table. Moving on to the next topic. This is the output that we got for the expense tracker that we implemented using binary search tree. The output of this program is a table displaying the user's input expenses in ascending order based on their amounts along with the total amount spent. Each row in the table shows the expense, ID, description, and amount for each expense. The expenses are presented in ascending order of their amounts, making it easy for the users to see their expenses sorted by cost. At the end of the table, the program calculates and displays the total amount spent, which is the sum of all the expenses. Moving on to the next topic.
A stack based expense tracker is efficient, simple, and lightweight, making it ideal for situations where you need to quickly log and track your expenses on the go. While it serves as an effective tool for basic expense tracking, it may not meet the requirements of users seeking organized expense management for them. The binary search tree based implementation might be more suited. Moving on to the code explanation part.
Okay, so this code also we have written in C language. As you can see, we have created two structures. One is expense that will represent an individual expense with fields like data, ID, description, and amount. And the expense stack structure is to stack data structure to store expenses. Moving on to the function initialize stack, which initializes stack by setting the index to -1. Then we have the push function, which adds an expense to stack if there is a space. If the stack is full, it will print an error message. Next, as you can see, there is a pop function. The pop function basically removes and returns the top expense from the stack if the stack is not empty. Otherwise, it returns an empty stack. Moving on to the display table function. This function will print our output in a formatted table displaying the expenses in the stack. Then the calculate amount function basically calculates the total amount spent by summing up the amounts of all the expenses in the stack. Next, we have the output of the function. In the output, as you can see, the expense that we have added at the very first is showing at the very bottom, and the expense that we added at the very last is showing at the top. Since stack uses LIFO approach, the first expense would be bought at the bottom and the last one would be at the top. Next, we have calculated the amount of all the expenses at the very bottom. Moving on to the next part.
So the next topic is comparative analysis. First is efficiency. The expense tracker based on binary search tree is well suited for intricate financial analysis due to its strong capabilities in searching, sorting, and retrieving expenses. On the other hand, the stack-based expense tracker is highly efficient in tracking the total expense, but lacks advanced features such as sorting and individual retrieval, which is in the binary search tree. Now, moving to the search and retrieval part, the stack has limited capabilities for searching and retrieving individual expenses. In contrast, the binary search tree provides efficient data retrieval and sorting features.
Comparing on the basis of space complexity, the stack has lower space complexity due to its linear structure and simplicity, while BST consumes more memory due to its hierarchical structure. On the terms of time complexity, while the stack based implementation might be simple and efficient with the time complexity of O of 1, it still lacks ordering. The binary search tree implementation offers efficient sorted order with the average insertion time of O of log n. Speaking onto the next topic.
So the conclusion drawn from both the programs is that if you want a simple way to track your expenses and don't need the fancy features, then you should go for the stack-based tracker. It's like quick and easy. On the other hand, if you're into detailed financial analysis and want advanced features like sorting and searching, the binary search tree based tracker is the way to go. It's smarter organizer that helps you understand your finances better. So I would suggest pick the one that fits your need, simple and quick with the stack, and detailed and organized one with the binary search tree. Thank you.
Well, as Misha said, ultimately the choice between the data structures should be driven by your specific needs and the nature of the data that you're managing. Whether it's real-time data processing, historical tracking, or data organization, understanding the strengths and weaknesses of these structures is very essential. Our exploration has not only deepened our understanding of these data structures, but also highlighted their real-world applicability. We hope that this presentation has been informative and aids you in making informed decisions when choosing the right data structure for your own project. Thank you for your attention, and we invite any questions or discussions in the comments below. Thank you so much.